Okay, this is the second video of 8.5 exponential and logarithmic equations. So continuing from the previous video, we're going to now look at solving the following equation. Okay, so we first want to get the part that has the exponent by itself. So we will subtract 5 from both sides. That will cancel. We'll have a negative 3 to the x is equal to negative 45. And this negative in front is not in parentheses, so that means it's really a negative 1 times 3 to the x. So we still need to get rid of that negative 1, which we can do by dividing both sides by negative 1 and getting 3 to the x is equal to 45. So from the previous video and lesson, we have a couple of ways we can do this. We can either take the common log of both sides, log base 10, or we could take log base 3 of both sides. So if we take the common log of both sides, log of 3x is equal to log of 45. Then we'll bring our power in front by the power property and get x times log of 3 is equal to log of 45. Now we can just divide both sides by log of 3 so that we get x by itself here. Divide both sides by log of 3. These cancel. And I get x is equal to log of 45 divided by log of 3. So plugging that into our calculator, we'll get log of 45 divided by log of 3 will give us about 3.4650. 3.4650. And you can also plug this back in to check that it is correct. Okay, moving on here. So again, we can either do it by taking log base 5 of both sides or taking the common log of both sides. So I'll do this one with taking log base 5 of both sides, since the previous one we did common log. So log base 5 of 16. Bringing our power in front here, I'll have a 2x times log base 5 of 5. And here I can use my change of base formula, log of 16 over log of 5. And for this, that's a 5 there. For this, log base 5 of 5, we know that's a 1, because when these are the same number, it's just going to be a 1. So we'll get 2x is about, I'm going to evaluate log of 16 divided by log of 5. So log of 16 divided by log of 5. And that's going to give us about 1.7227. And I just used my calculator for that. Dividing both sides by 2, I get x is about, dividing by 2, and I get 0.8614. And that's our answer for that. Okay, moving on here, solving a logarithmic equation, and we have to solve and check. So what we need to do here is we need to remember that if there's no base written in, it's a 10. So I'm going to change this, write in exponent form. So we know that if I have y is equal to log base b of x, that is equivalent to b to the y is equal to x. So I'm going to change this here to 10 is my base to the 5th power is equal to 3x plus 1. So we'll evaluate this here. 100,000. So, and then we were able to get this because of the base of 10 here. So we will rewrite this 3x plus 1, subtracting 1 here, and subtracting 1 here. This will cancel. 99,999 is equal to 3x. Dividing both sides by a 3. And x is equal to 33,333. And then we need to also check this. So we can check this by plugging in x. So we're going to say log of, I'm going to plug this in, 3 times 33,333 plus 1. Let's see what that's equal to. So this is a log of 99,999 plus 1. Whoops. That should be around the 1. And then that is log of 100,000. And you could just plug that into your calculator. And you get it equal to 5. Okay, and this one here, actually we can move on, do another one. Okay, this is, if log of 12 is about this amount and log of 3 is about this amount, we need to find the value of log of 1/4 without a calculator and explain how you found the value. So if we do this and we want it to be equal to log of 1/4, well, we know that when I'm subtracting logs, log of 3 minus log of 12, when I'm subtracting logs, I divide these numbers. So this is equivalent to log of 3 over 12, which is log of 1/4. So these are equivalent statements. This is equal to log of 1/4. So I can just take log of 3, which I know what it's equal to, minus log of 12 and evaluate that. So I'll get 0.4771 minus 1.0792. This was by the quotient property, by the way. And we just plugged these in because they told us what it was equal to. And that will give us negative 0.6021. Okay, and then a few more here, using logarithmic properties to solve an equation. So what we're going to do is we want to make it a single log first. So I'm going to take this 2 and put it as the power first. So that will give me log of x squared minus log of 3 will be equal to 2. When I'm subtracting logs, I divide these. So I have log of x squared divided by 3 is equal to 2. And here, notice there's no base written in, so it really has a base of 10. So that will be 10 squared is equal to x squared over 3. And 10 squared is 100. 100 is equal to x squared over 3. Multiply both sides by a 3. And we get 300 is equal to x squared. Taking the square root here. And we get x is equal to, when we take the square root, we can write it as square root of 100 square root of 3, which is a 10 square root of 3. Or you can plug that into your calculator, and that's about 17.3205. Okay, one more here, which is similar. We're going to write it as a single log first, so we're subtracting again. So I'm going to divide 6 over 3x is equal to negative 2, log of that. Again, there's no base written in, so it's a base of 10. So I'll have 10 to the negative 2 is equal to this whole thing, 6 over 3x. Okay, and then I can evaluate 10 to the negative 2 is the same as 1 over 10 squared. By, if we bring this to the denominator, it will get rid of the negative exponent. So this is 1 over 100 is equal to 6 over 3x. I can go ahead and cross multiply here, so that will give me a 3x equals 600. Just by multiplying 6 times 100 and 1 times 3x. Dividing both sides by a 3, and I get x is equal to 200. And that's our answer for that. That's part 2 of 8.5 exponential and logarithmic equations. Thanks for listening.